Hello everybody, welcome to 101 Computational Problems, where I've got a special version of a problem that's not included in the book but actually came from a video from Big Clive, which I'll put in the video now a link to. Clive was talking about roulette wheels, and he had an old roulette from an arcade, a British arcade, and that roulette wheel had 25 positions, as you can see detailed on the screen here. This is the stats of this, and 2p per play, and producing some kind of wins with blue, red, green, yellow and white sections that you could say that you could bet upon, I suppose. Okay, I'm not advocating betting, it's just an interesting probability problem. And at the time, in Clive's Patreon page, he says he reckons the house cut is 4%. That's interesting, given X number of people playing it. You know, what percentage does the house get from people's betting, from people's 2p's that they're putting into this machine? So do check out Clive's video, because it's really interesting in Clive's unique style, and it's well worth watching and following. So let's make this into a Python problem we can solve. So a couple of things I think about first of all when I see a problem like this. I've got some colours and I've got some numbers, and I suppose I'm picking one of them at random. So I don't quite know this at this point, but I'm going to be dealing with something random. So I know I'm going to probably want to import the random module to help me deal with some random numbers as things go on. The second thing I probably need to think about, and I'm going to think about this in the order that I would think about the problem, is I now want to pick one of these random numbers. There's 9 blues, 8 reds, 4 greens, 3 yellows and 1 white. So I need to pick a random selection from those collection of things. So the way I go about thinking about this is I'm going to set up a function called wheel, which I suppose is the entirety of the roulette wheel. And I'm going to put into that wheel 9 blue positions, 6, 7, 8, 9. So that's my 9 blues, my 8 reds, my 4 greens, my 3 yellows, and my 1 white. Okay. So at that point, I've got all of the options that are available to be selected on the roulette wheel, and I want to pick one of those from random. Okay, so if I was to literally just issue the print command, and I'm going to print a random choice, that's how we use from importing the random module, random dot choice from wheel. Okay. Now, if I run that, I would expect to get a B, an R, a G, a Y, or a W. But of course, there are more B's to choose from. So if I was to do the odds of this and do it hundreds of times, I would expect to get more B's than anything else, then more reds, then greens, then yellows, and then whites would be the least common thing. So if I print random choice from wheel, I'd expect an answer here that is an R, a B, a G, a Y, or a W. There we go, and I get a B. I run it again, I get an R. I don't imagine I'm going to get a G next time. No, I've gone back to B. So every time I've run this, that print random choice function is actually taking one of the random characters from that string, which is called wheel. So I'm going to clear the output, and I'm going to get rid of that print random choice. It's just establishing how this works. And I'm going to think about a function, which is, let's call it play. So I'm going to think about a function, and when you play roulette, you pick a value. You put your money against one of the colours, and hopefully if that colour comes up, you win a certain amount as is indicated in the rules above. So into play, I am going to pass my bet. I'm going to tell it whether or not it is blue, red, green, yellow, or white. Okay, so my function is define play, into which I'm passing bet. So let's have the original, the number that the roulette wheel is returning, which is going to be the ball, the value of the ball, that is going to be this random.choice of the values in that wheel. Thick fingers tonight. So the ball is random.choice of wheel. So every time I run this function, it'll recreate ball and it'll give it a B, an R, a G, a Y, or a W. So that's fine. So if at this point, if ball equals, now I suppose I want to say if ball equals whatever, okay, if ball equals the same as what I've bet. So I'm passing it into bet. So if ball equals bet, so if I've won something, so if I've picked white and it's landed on white, yeah, if ball equals bet, in fact it's equals bet, if ball is exactly the same as bet, what am I now going to do? Well, at this point, if the ball, it wouldn't matter which I chose, but I'm going to go, I could have said if bet, but I'm going to go if ball equals B for blue, okay, at this point I am going to win a certain amount of money. I'm going to win, from the description, I'm going to win 4. And I'm going to say if ball equals, make it the same, equals red, I'm going to win 4. Ball equals, at this point, where else have we got? Green, that was the next option. Ball equals green. Can't remember how much I win. How much do I win for green? I win 8 for green. I win 8 for green. If ball equals, what else have we got left? What was after green? Yellow. If I get yellow, how much do I win? I think it was 12, wasn't it? Yeah, 12 and then 32. I win 12. And if ball equals white, it's going to allow me to win 32. And I end up winning 32. So I've made a function. Is that all I need in my function? So I've made a function that says I'm going to pass it into bet. I'm going to push into it a thing I've chosen. I'm going to roll the ball to pick a random colour. If they equal each other, which is what if means I've won. If ball is blue, I win 4. If ball is red, I win 4. If ball is green, I win 8. If ball is yellow, I win 12. If ball is white, I win 32. And at that point, I want to return the value of the winnings. Okay, I want to return the values of the winnings. But I've got an else condition, which is, what if the ball doesn't equal the bet? What if I lose? Well, if I lose is simple. I win nothing. I win nothing, and I still return the value of that winnings. Okay, so there's my function for rolling a ball. Scroll out a little bit so we can see it all. So if I now issue, let's say I'm just going to print, keeping the white space correct, I'm going to print, I'm going to play, and into play I'm going to, let me just say I'm guessing B. I'm putting my money on blue. So print play blue. I'm either going to get I've won 4 if it matches by luck, or I'm going to get I've won nothing. So if I run this, I'm expecting print play of B to either be 4 or 0. Oh, and it's crashed. What have I done wrong? Name random is not defined. What we get for live coding. So it should say random. I can't spell. And there it is. A random choice. So now if I rerun this code, it should give me a 4 or a 0. It's giving me 0. Let me run it again. And again. And again. There we are. I've got a 4. So it appears that this is now passing the correct functions. But let me just say it's a W. So I'm either going to get 0 or 32. But W is going to be much less frequent because initially all of these characters were not W. And I've got only a 1 in, what is it, 25? Yeah, 25 positions. So I've only got a 1 in 25 chance of getting a W. So if I run this, I'm pretty much guaranteed to get a 0. If I rerun the code 25 times, statistically I probably should get a W for once. So there we go. I'm going to get rid of that. I've got a function now that effectively places a bet, if I'm passing it my guesses. So I'm going to think about now creating something that loops through a number of times of playing this game. So to do that, I'm going to have to think of some more conditionals to start off with. And that is, I'm going to start with a balance, okay, of 100. As in, I'm going to start with £1. All right, start my betting with £1. I'm going to talk about the stake being 2p. It's going to cost 2p per go. And I'm going to talk about number of spins being 50p. Being 50 spins. And I've chosen those. That's not defined in the problem, but I've chosen 50 spins. We know it's a 2p stake, 2p for a go. So if we do 50 spins and we lose every time, we'll be out of money. So I'm going to set a limit on this simulation of 50 spins at 2p a spin is 100 pennies, which is £1. Okay. Everything out of 100 means the numbers I get back are percentages of some description. And we'll talk about that, because what we're looking for is the percentage of the chance, if you like, of me to win, which I suppose is equally the same as 100 minus the percentage that the house, if you like, the arcade keeps. So if I keep going with this code, the next thing I want to think about is I want to think about running through 100 versions, or sorry, 50 spins. I want to go through 50 spins to see where we've got. So if I need a for loop. So if I just go for a for, and I'm going to use the underscore, which is a temporary throwaway variable. So for scratch, if you like, for nothing in range spins. So that will go from 0 to the number of spins, and it'll stop at the number of spins. So essentially it will give me 100, or in this case 50. It'll give me 50 iterations of this for loop. Okay, so I've got a for loop that spins round. Every time I play, my balance is 100, but every time I play, I am going to take 2 off that list. So at this point, I'm going to take my balance, and I am going to deduct from my balance 2. So balance equals balance, take away 2. My balance has gone down by 2. So now I'm going to issue the bet. I'm going to issue my bet command. So I actually want to say balance plus equals, and then I want to play, and I got to put something into play. I could pick, what if I want to pick and I want to stick with blue? Okay, so I'm going to play blue. So what this is going to give me is going to give me 50 spins where every time I am sticking with blue. So if at the end of this for loop I am to print my balance, okay, what this will do after 50 spins, it will print out my balance. Bear in mind I started at 100. What's my balance gone down to after 50 spins? It's either gone up if I've won on multiple times, or actually after 50 spins, how much money have I got left? If I run this, I get 76. I got 76p left after 50 spins where I bet exclusively on blue. If I was to bet on white, for example, I got a far less odds of getting white, but the odds of winning are higher. So if I rerun this code, I'm going to get a different number down here. What I get is 96. So for this particular set of 50 spins, betting on white repeatedly produces 96. I've still lost 4p. I've still got less money than I started with. But in this case, the house's cut was only 4% of the money that I put into the machine in the first place. So what I want in here is I want a way of passing into play all of the values, a B, a red, a yellow, a green, and a white. Okay, so what I'm going to do back up here, I'm going to define, let's call it bets, okay? And in bets, I'm going to define bets as being just the colours that are possible. So blue, red, green, yellow and white. They're the possibilities, okay? Because I've got a string, it means I can iterate across it. So in here, I can, for scratch in spins, so for those 50 spins, okay, I can wrap another function around the outside of it. So if I shuffle those over here, I can wrap another for loop around that, which is for I in bets. And what that will do is it will start at the first entry in bets, which was blue, B. And the first time this for loop runs, it will push a B, the I in this for loop will be B, and then it'll go to red, green, yellow and white. So for I in bets, I want to go through all of the colours and I want to play, and in here I'm going to play I. I'm going to send into my betting function the I value which has come from that string of bets. And then once that is finished, I'm going to, once that for loop is finished, I want to stay here. So I want to stay inside my I for bets. I want to iterate through the 50 spins, print out the balance, and then I want to go round the loop again, and I want to move on to the next value. So every time this function starts, I actually need to set my balance back to 100. So the first time this runs for I in bets, it's B. The first colour is B. The balance is 100. So for scratch in range of 50 spins, it takes 2 off the balance. It adds to balance whatever my winnings are from playing the function, and it iterates through that 50 times. And then after 50 goes, it prints out my balance. So just to keep this sane, let's add betting on space comma I, which will show me the letter that I'm betting on I, and I keep, if you like, this much money. So this should go through blue, red, yellow, green and white, and it should tell me after 50 spins how much of my money I've got left. So I should get a bunch of answers for this when I run this. There we go. Betting on blue and I keep 92. Betting on red and I keep 76. Betting on green and I keep 48. Betting on yellow and I keep 60. Betting on white and I keep 64. So what that's saying is the best betting option is betting on blue. And I guess that would kind of show you, because that's because there's the more of these, but you win the least. But if you consistently bet on blue every single time, for this range of 50 spins, you would end up getting 92p back. So the house keeps 8p. So what I want as well maybe is a different strategy, which is, what if I actually just want to choose a random value? I don't want to just pass in the colours, pick all blues, pick all yellows and so on. Okay, so if I stick outside for I in bets, if I here now have another iteration, okay, so I'm just going to go under here and I'm going to go for here, I'm going to go, no, do I want to I in bets? No, I probably don't, do I? So I'm going to go here now and I'm going to go for scratch in range spins. So I'm going to do another set of spins, all right? So another set of 50 spins, and this time, just like previously, I have to reset my balance. So balance is back to 100, okay? And here now, what I'm going to do is I'm going to do, no, balance is 100. So balance is, no, I don't want balance 100 there, do I? I want balance as 100 here. I'm resetting my balance. So now I'm in this loop, and now I'm in the for loop here. I am now in this loop going to do balance minus equals 2. So I'm playing a go, and then balance equals, and what I want to do, like previously, so balance plus equals, and this time I want to issue the play function, but instead of passing blue, red, green, yellow, whatever, this time I'm going to pass it a random choice from bets. Okay, so I'm going to randomly pick what I'm going to bet on, and I'm going to do that 50 times. So if I move this code from here, and I move this code to underneath, cut and paste it underneath, this time I'm going to say under here, I'm going to say betting randomly, comma, I get to keep balance. So the best bet was 92, the worst was 48. So I'm expecting a random answer to be somewhere between 92 and 48, I suppose, somewhere in between. So I'm going to iterate through, balance back to 100, iterate through all of the spins, so my 50 spins again, where I'm passing into random choice bets. I've set my balance back to 100. Okay, so if I run this now, I should get my blue, red, green, yellow, white figures, and then underneath it I should get another line that says betting randomly I get to keep. Let's see how this goes. There we go. So this time the numbers are different, but betting randomly you get to keep 68. So that's only for 50 spins because of the way I've set this up. So what I think I would like to do is I'd like in some way to run multiple versions of multiple goes at doing this set of coding, this set of 50 spins. So around here for I in bets, what I could do for I in bets, and I can push all of that over here now, could wrap another for loop, which is for, again, I'm going to go with scratch because it doesn't matter, in range 1000. So what this is going to do is it's going to do 1,000 lots of all of the betting of these 50 numbers as I did previously. Okay, so if I do that, I'm going to have some way of storing the output of each of these sets of, you know, the for balance by, instead of printing out the balance here inside this for loop somewhere, I need some way of allowing me to keep the balance in some way, shape or form. I need to append some values into appropriate arrays. So if I go up here, I'm going to make some lists, and I'm going to have lists for all of the different colors, because I'm going to have the lists to store the results from each one. So I'm going to have blue as a list, I'm going to have red as a list, and I know there's probably more efficient ways of doing this. I'm going to have green as a list, fat fingers. I'm going to have Y as a list, yellow for a list. I'm going to have white as a list, and then I'm going to have the random choice that I picked as a list. Okay, so there are some lists here into which I can store the output of each of these things. So in this loop here, there is my 100 spins for a particular thing. So inside that loop, inside the loop here, so for X in range spins, when that loop has finished, I want to add the value of that to the thing that I've created. Well, how much money have I got left for constantly betting on B? I need to pop that into the list for B. So the way we're going to do this is I'm going to create another little variable called data. And what I'm going to do is I'm going to evaluate I. What I want from this I thing that's coming around here is I don't want I can't just say I need to know the value of I to which I'm going to append. So data.append into my list, I'm going to append the balance. Okay. When this runs, data will evaluate I, and the first time this runs through, and we're in I for bets, and we're in the color string, the first time this runs, evaluating I will give data the value of B. So here, even though I've got data.append, what I end up with is b.append, because the first time round, data will equal B. Okay, so data.append balance. So this will run 1,000 times. So this loop here, up to this point, will run 1,000 times, and I'll get for I in bets. And every time this goes around, I will get into this. I will get a.append. I'll get a list of values for reds, for greens, for blues, and I will get a list every time this goes round 1,000 times. I'll bet on blue, I'll bet on red, I'll bet on whatever, and it will give me lists that have got all of the output from this in. Okay, I want to do the same thing here, but what I want to do here, I want to print out not the balance, I want to print out the average balance of what will be in this array here, this list here. So the way I'm going to do this is I'm going to import another module, and I'm going to say from statistics, I'm going to import mean, just because it makes my life easier, which will allow me to take and make a mean of a list. So at this point here, print, let's take that back down there. So print betting on, need to be a bit clever in how I do this, don't I? Yeah. So what I'll have here now, I will have a list of B, which will have a whole bunch of numbers in like this, and there'll be 1,000 of them, and it'll be the same for red and green and yellow. So what I need to do is I possibly need to make slightly more print statements. So what if I did the average, if I print the average, and this time it's after 1,000 runs of 50 spins, okay, by betting, I can't spell, just on, and in this case, just betting on B. All right, we'll change that in a minute, you'll see for why. Betting just on B is, okay, and then what I need to issue is I'm going to issue the mean of B, because B is that list that we've just generated, and I actually want to turn it into an integer because it will be a decimal value, but I just want one value. So what that will do is it will print the mean of the opportunities, or the returned value I get for betting on B. So what else have we got? We've got red, so I want the mean of red. We've got green, so I want the mean of green. We've got yellow, so I want the mean of yellow. And we've got white, so I want the mean of white. So that's fine, that will do everything we need. Doesn't quite do it down here for random, does it? So I need to do the same thing where let's take all of this and shovel it over here. And I'm going to make another for scratch in range 1000. Okay, so every time that loop runs, I want the balance to go back to 100. And then I'm going to do for scratch in range spins. So it's the same deal, but I'm going to take the code I've done here and I'm going to pop that there. But I don't need to data eval I. I'm just data appending. It's not data, is it? Because I had rand. If you remember, I made at the very top, I made another list that was just called rand. So this time, the list that I'm appending to is called rand. So my print statement is going to look like this time. Make sure I get it all aligned properly. After 100 spins of betting randomly, okay, is ... int mean w rand. So what's not going on here? I don't think I've got my I think they line up now, don't they? Yes, they do. Got my appropriate numbers of brackets. So let's just sanity check this. I'm importing some modules. I created a string called wheel, which we know works from previously. I've created a string called bets. I've created a bunch of lists that are empty to store the intermediate answers from the 50 spins, balanced stake spins. We know the bet function works because we tested that at the start. And now I'm doing for scratch in range 1,000. So for 1,000 plays, for I in bets, we're going to go through the colors, and we're going to do, for each of the colors, we're going to do 50 spins. And once those 50 spins are finished, we're going to add the value to whatever the list that comes out. So the first time it'll evaluate to, say, B. So data.append, it will append to the B list. And then after 1,000 runs of 50 spins, it's this. And then it should do the same thing. So let's clear the output and run the code. There we go. So the average after 1,000 runs of 50 spins by betting on just blue is 71. So this is much more accurate now, much more close to the real value from calculating the odds. And after 1,000 runs of 50 spins by randomly betting is 67. So the house keeps what? Between 37% here, the house has kept 37%, or here the house has kept 29%, 28%. So depending on what you bet on, the house keeps about 30% of the value that you've bet on the wheel. In terms of what's best for you to bet on this wheel, well, betting's never good in any way, shape or form. But if you're in one of these arcades, if you consistently put your 2p's and bet on the B, of course you would lose money overall, but you're going to lose less money. Of course, what this doesn't account for is putting 2 bets on white and then coming up 32 winning twice. So in terms of your fun, obviously you'd have a longer set of games, you would play for longer if you carried on just betting on blue, but in terms of fun, it might suck the fun out of the whole thing. So there's a really quick bit of Python code around Big Clive's roulette wheel that he did a video on. So again, I'll link to Big Clive's video. This has been 101 Computational Problems. My name is Glenn Gilchrist. Thanks for listening. Give me a like and a subscribe if that's the way it floats your boat. Thank you.